Alright, so let's talk about this problem here. It asks us to find each of the following, or evaluate would be another way to say it. This symbol is known as an absolute value, and just in case you don't know what it does, let's use a calculator to do it, and maybe it'll become kind of obvious what it does. Alright, so these are all equal to some number. So the absolute value on a calculator can be found in math. Alright, so in math, it's in the number section. Push right to number. It's right up top here, ABS, absolute value. On the newer calculators, it actually comes out as an absolute value symbol. Let's see what the absolute value of 5 is. It's just 5. Alright, so the absolute value of 5 is 5. Let's see what the absolute value of 4 is. Oh, something I think I've mentioned before. If you press second, then enter, it brings up your previously entered line. Now I can just go back in here and enter -4 without having to go find the absolute value buttons. Just enter, and it says it's 4. Interesting. And what is the absolute value of... Oh, if you do it again, it'll go to the previous line. So it'll continue to go back one line. Absolute value of 0 is 0. So it may be clear as to what's happening, but it may not be clear. The absolute value of a number is its distance from 0 on a number line. Oops. So 5, if this is 0, 5 would be located over here. The distance from 5 to 0 is 5, whereas -4 is located over here, and its distance is 4. And 0 is at 0, so its distance to itself is 0. So as you might have noticed, the absolute value of any number must be positive. If the number is negative, it becomes positive. If the number is positive, it stays positive. Alright, now the reason we bring this up with this lesson about the order of operations is that it's a symbol that's going to be used every once in a while, and you need to know how to deal with it, because absolute value is not part of PEMDAS, or Please Excuse My Dear Aunt Sally, as you may remember. So let's take a look at an example. Alright, so we're going to evaluate this expression. We're going to use the order of operations for this. Firstly, let's enter this into a calculator and see what we're supposed to get. We need a fraction, so alpha, y equals n over d. So it's -6 times 3 minus 5. Alright, plus 6. Oops, I need a parenthesis here. You can enter the entire thing into a calculator, but it is preferable that you do this by hand, showing each part as you go, which is what we're going to do. We're actually going to take the square root of 2 minus 1, and then we're going to cube that to the third power, the power of 3. So this is what's in there what's on the screen, same thing as here. This should evaluate to be 30. Alright, so that's going to be 30. Let's see if we can figure this out. Now the order of operations says we should do parentheses first, so that would be here and here. Right? There's a small error with that. Order of operations is not, the way you may have learned it, is not necessarily correct. So the correct way to use the order of operations is here, and that is first you use grouping symbols. These are all grouping symbols, not just parentheses. Anything that groups a set of items together. So parentheses definitely group items. The absolute value symbol groups items. Radical symbol groups items, such as this 2 and -1 and -1. The numerator of a fraction is a grouping symbol. You have to do everything up here before we can do this division. We also have to do everything down here before we can do this division. We can't divide by this radical before figuring out what it is. Alright, so following the order of operations, you'll also notice I did not list division, because that's just, as we saw in the previous video, multiplication by the reciprocal, so they are of the same level of importance. And subtraction is really addition by a negative number, so they're the same. Alright, so this is multiplication or division. And this is addition or subtraction. Alright, so looking here, the first thing we have is We have a fraction, which means we're going to do the numerator and the denominators before we can do anything else. So it doesn't matter which one we do. We'll just do the bottom one, I suppose. All right. So 2, I'm going to move the answer for now. I don't want it to get in the way. All right, so 2 minus 1 is 1, so this is now 1 to the third power, well, the square root of 1 to the third power. The square root of 1 is 1, so that's 1 to the third power, so we're going to get 1. Now, working out the numerator, this is negative 6 times 3 minus 5 is the same thing as 3 plus minus 5, which is negative 2. And this is plus 18. Alright, so we did all of the grouping symbols together. Now we're going to do the rest of the numerator. Negative 6 times 2 is 12. 12 plus 18 is 30, so this is 30 over 1, which is equal to 30. So if you follow the order of operations appropriately, you will get the expression you're supposed to get. If you don't follow it appropriately, you will get something else. Now, who decided on the order of operations, and why should it go in this order? Well, it was decided so that people can read each other's work and figure out what they did. By using any other order, this becomes a very interpretable thing. If we multiplied the 6 and the 3, ignoring the parentheses, or maybe added this term and this term before multiplying, we'd get a different value, and that's not necessarily what the person who wrote this expression would want. So order is important.